Let me show you another problem of annuity. What amount of money invested today at 15% interest can provide the following scholarship? 30,000 at the end of each year for 6 years, 40,000 for the next years, and 50,000 thereafter. For our cash flow, so you want to receive, or your scholar receive 30,000 each year for 6 years. And then 40,000, another 40,000 for the next 6 years, every year. And then after 12 years, you want to receive 50,000 thereafter. So from the cash flow, so this we want to determine if how much money you want to invest, so that you will receive this amount, 30,000 for the first 6 years, then 40,000 for the next 6 years, then 50,000 thereafter. So here in order to determine the amount that you will be deposited today, so we see today as the focal date. So the amount of money you want to receive for 6 years, so the present value of the money you want to receive for 6 years, then the present value of the money you want to receive for the next 6 years, and the present value of the money you want to receive thereafter. So here, you want to receive 30,000 each year for 6 years, then 40,000 each year for the next 6 years, and 50,000 each year for thereafter. In order to determine if how much money you will be invested today, so we determine the present value of all this amount. The present value of your 30,000 you receive for 6 years, the present value of the money you receive for 40,000 every year for another 6 years, and the 50,000 you want to receive after 12 years thereafter. So setting today as the focal date, so our equation of value is the present value of your 30,000 plus the present value of your 40,000. So here, the present value of your 40,000 is simply a case of deferred annuity. So the present value of your 40,000, then using compound interest formula, then we can determine the present value of your 40,000 using today as the focal date. So here, the present value of your 50,000 thereafter, or your perpetuity, so you have P over I. Then in order to determine the present value of your perpetuity, so we use the simple compound formula using F, given the value of F, N, and I, we can solve the value of P. So the present value of your 50,000 perpetuity. So we have 15,000 over 0.15 times P over F, 15%, and 12, or the number of periods is 12. So the total number of, the total equivalent value of money at the present, so the present worth of the total value of money, or the total future worth. So this is the total future worth of your money, and you want to convert them into the present value. So this is now the present value. So the present value of your 10,000, the present value of your 40,000, and the present value of your 50,000 thereafter. So P is equal to 30,000. So substitute the given interest is 15%. Then N, for the 30,000 you want to receive for the first 6 years. So that's why we have -6. Then for the 40,000 you want to receive for the next 6 years. And then finding the solving the present value of your 40,000 base 2D as the focal date. So you have 1 plus 0.15 to the power of -6 plus the present value of your 50,000 perpetuity, or the amount you want to receive uh, starting 12 years. So you have P equals to 241,477. So in order to receive 30,000 for the first 6 years, then 40,000 for the next 6 years, and 50,000 thereafter, you need to deposit today 241,477 pesos.